In this video, we're going to be talking about zeros of polynomial functions. So let's start by going through how do we know how many real zeros a function will have. So again, we're talking about real zeros. To do that, we're going to look at the degree of the function because f has at most n zeros. Well, how do we know how many relative extremes or the function has? So when we're talking about a relative extreme, we're talking about either a relative minimum or a relative maximum. And for that, we're going to look at the degree of the function and know that f has at most n minus 1 extrema. So if I had a function that was to the third degree, then I would expect to find at most 3 zeros and 2 extremas, either minimums or maximums. Now, when f is a polynomial function and a is a real number, the following statements are equivalent. Let's go ahead and let's move this up. First, x equals a is a zero of the function of f. Next, x equals a is a solution of the polynomial equation f of x equals 0. Third, the quantity x minus a is a factor of the polynomial of the function of f. And fourth, a comma 0 is an x-intercept of the graph of f. So remember, we were talking about this makes the statements equivalent. Well, it doesn't make them, but all 4 of these statements are equivalent. So now we're going to do a couple examples where we're going to find all real zeros of the relative extrema, and the relative extrema of the 2 examples we have here. So in our first example, we have f of x equals x to the third minus x squared minus 2x. So the first thing we're going to do is we're going to replace our f of x with a 0. Then here we see that we can factor out an x, so we're going to do that, which leaves us with x times x squared minus x minus 2. And from there we can factor that. So we'll have x minus 2 and x plus 1. And when we do the zero product property, we find that we have values of x equals 0, x equals 2, and x equals negative 1. It's important to make sure that you check your solutions. To save time, I've already checked these. So I've already plugged them back into my function and seen that it is in fact a solution. So I've plugged it back into here where we have our 0. And so I've found that x equals 0 is a solution, x equals 2, and x equals negative 1 all work out. Now notice that our polynomial here is to the third power, and we have 3 solutions. So we could have had 0, 1, 2, or 3 real solutions, and we have 3. Now to figure out what our relative extrema is, we know that if we take that 3, right, or degree 3, and we minus 1, we're going to have 2 extremas. So to find those extremas, we are now going to graph that. So let's go ahead and move this up a little bit, and let's open up our graphing calculator. So we'll go ahead and we'll put our equation into our graphing calculator. So we have x to the third minus x squared minus 2x, and we'll hit graph. And so we see here that we have a relative maximum and a relative minimum. So to calculate that, we're going to go to second, trace, which brings up our calculate menu. We will find our maximum first. So we want to be on the left-hand side of our maximum. Then on the right-hand side of our maximum, notice that my maximum is between my 2 dashed lines. Then I'll hit enter, and it will tell me that my relative maximum is at negative 0.55 and 0.63. And now we're ready to find our minimum value. So we're going to go to second, trace, brings up our calculate menu, and now we're going to calculate our minimum. And so we want to be on the left-hand side of our minimum, and then on the right-hand side of our minimum, notice that our minimum is between the 2 dashed lines. Then we hit enter, And we see we have a value of 1.215 or 1.22, comma negative 2.11. And so now we have our three solutions, and we also have our relative maximum and minimum. I want you to go ahead and try letter B on your own. So find the zeros, check your solutions to see if they work, and then graph your equation and find any relative extremas that you might have. So push pause to do that. Then when you're done, push play and let's see if you were right. So we'll begin by finding our zeros. So we'll replace our f of x with 0. And we're going to see that we can actually factor out a negative 2x squared, which will leave us with x squared minus 1. And we can go straight to the zero product property here. I'm going to write that out. So we have negative 2x squared equals 0, and x squared minus 1 equals 0. And we probably, looking at this right here, we probably could have factored that another time. But we can solve it as well right here, so we'll do that. And so here we will divide both sides by negative 2, leaving us with x squared equals 0. When we take the square root of that, we'll get a 0. And then over here on this side, we'll add 1 to both sides, leaving us with x squared equals 1. And then when we take that square root, we'll have x equals a plus or minus, and the square root of 1 is 1. And so here we see that we have the opportunity to have 1, 2, 3 solutions. So now we want to take those and we want to plug them back in up here to see if they do indeed work. And when we do that, we see that they do work. So we have x equals 0, x equals positive 1, and x equals negative 1 as solutions. We're going to find our power. We have a power here of 4. So if we take our 4 minus 1, we're looking for 3 extremas. So let's go ahead, let's scoot this over, and we'll pull up our graphing calculator. And we'll plug in our equation of negative 2x to the 4th plus 2x squared. And we'll hit graph. And we see that we do in fact have 3. It's kind of small. There's one here, here, and here. So if we want to get a little bit closer look, we can hit zoom. And we can zoom in, which is option number 2. We see that our cursor is at the origin, right at the center. We'll hit enter. And we'll have a little bit better view of our 1, 2, 3 relative extremas. And we see that we have 2 maximums and 1 minimum. We're going to go ahead and we're going to calculate our first maximum. So we'll go to the maximum on the left. So we want it to be the left side of that value. So here we go. So now we're on the left side, and now we want to be on the right bound side. Notice that our maximum is between our 2 dashed lines. We'll hit enter and have a value of negative 0.707, so negative 0.71, comma 0.5. So now we have a choice. We can either find our minimum or find our other maximum. I'm going to go ahead and I'm going to find our minimum. So since we're just kind of moving from the left to the right, so I'm going to choose option number 3 for minimum. And I want to be on the left-hand side. And then over to the right-hand side of my minimum. And notice that my minimum is between the 2 dashed lines. I'm going to hit enter. And here I'm going to have a negative 6.854 e to the negative 7. That e to the negative 7 means that there are 6 zeros in front of the number 6. So that's pretty much the number 0. Then over here we have e to the negative 13. So that's definitely going to be a 0. So we're going to say that this is 0, 0. And now we have to find our last maximum. So we're going to go second, trace for our calculate menu, choose the 4th option for the maximum, and now we want to make sure that we're on the left-hand side of the maximum, hit enter, then move to the right-hand side of the maximum, make sure our maximum is between the 2 dashed lines. If it's not, you need to quit out, so hit second mode, and try again. But if you are, great, hit enter. Here we see that we have a value of 0.707, so we'll round that to 0.71 and 0.5. So now we found all three of our solutions and all three of our extremas, our two maximums and our minimum. And so here, we've got as part of our solution. And so that's how you find all of the real zeros and how you know how many zeros or solutions you should have and how many maximums or minimums you should be expecting to find as well.